When you roll a die, it feels like chance is in control. You shake your hand, release the cube, it bounces, spins, collides, and a number appears. Most of us call that randomness. But here's the uncomfortable truth. Dice are not truly random. In the early 19th century, Pierre-Simon Laplace proposed a thought experiment. If a vast intelligence knew the position and momentum of every particle, it could calculate the entire future. This is Laplace's demon. Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world. Dice only look random because we don't understand or can't measure what's really happening at the level of classical mechanics. Every single dice roll obeys the same laws that govern planets, pendulums, and falling apples. There is no special luck variable in the equations of motion. Newton's laws, classical mechanics, deterministic physics. We are talking about torque, angular momentum, and kinetic energy dissipation. Nothing mystical, nothing lucky. When a die leaves your hand, its outcome is already encoded in reality. The system is deterministic from the moment of release. The force of your fingers, the precise angle of release, the initial angular velocity, the height above the table, even the friction coefficient of the surface, even microscopic imperfections on the die itself. A fraction of a millimeter off-center in the weight distribution can bias the result over thousands of rolls. Change any one of these slightly, and the result changes. This is the definition of a non-linear system. But if you could measure all of them precisely, the final face of the die would be predictable. This isn't speculation. It was demonstrated experimentally by Percy Diaconis. Before becoming a mathematician at Stanford, Diaconis was a professional magician. He knew how to control what others thought was chance. He didn't just study probability, he performed deception. He realized that a coin flip, for example, is actually biased towards the side that faces up when flipped. And he asked a dangerous question. What if dice rolls are not random events, but chaotic systems that are simply too fast for us to see? Together with physicists, he built controlled dice-throwing machines. These weren't for gambling. They were precision instruments designed to eliminate human inconsistency. The result was shocking. When dice were launched with the same initial conditions, same angle, same spin, same force, they landed on the same number again and again. Randomness collapsed. What we call chance was revealed as hidden order. So why does dice rolling feel unpredictable? Because it's a chaotic system. Chaotic systems are deterministic, but insanely sensitive to initial conditions. A microscopic change at the start, a billionth of a degree in the launch angle, produces a massive difference in the final face shown. This is the same reason weather forecasts fail after a few days. The atmosphere follows physical laws, but tiny errors in measurement grow explosively. This is fluid dynamics at play. Your hand trembles by fractions of a millimeter. Your muscles fire with imperfect timing. We are simply too messy to produce the same outcome twice. You're not rolling randomness, you're rolling ignorance. We use chance as a placeholder for variables we are too limited to track. Casinos understand this very well. They don't rely on luck. They rely on physics and manufacturing standards. That's why casino dice have sharp, razor edges to maximize chaos upon impact. Even the tables are engineered to ensure the maximum number of collisions, making it impossible for a human to maintain a controlled throw. The randomness is forced by design. If dice aren't truly random, what about coin flips, shuffled cards, roulette wheels? All of them follow deterministic mechanics. They are all solvable in theory. Then where does true randomness exist? If the macro world is just a series of dominoes falling, is there anything that is truly unpredictable? Modern physics suggests that genuine randomness may only exist at the quantum level. Radioactive decay, the path of an electron. These are governed by probability wave functions, not classical trajectories. According to the Copenhagen interpretation, a particle doesn't have a single state until it's observed. The outcome isn't hidden. It literally doesn't exist until the measurement happens. But even this is debated. Einstein famously said, "God does not play dice with the universe." He believed in hidden variables, that even quantum mechanics is deterministic at a level we haven't reached yet. If true randomness is rare or non-existent, then how much of our lives is just complexity beyond our perception? Is luck just a word we use for the limits of our own intelligence? How many of our decisions feel unpredictable not because they are random, but because we are blind to the thousands of forces shaping them? We live in a web of deterministic chains we call freedom. Dice don't prove the universe is chaotic. They prove we are limited observers. The cube never guesses. It obeys the laws of the universe with absolute fidelity. Only we are surprised. If dice aren't truly random, do you think real randomness exists anywhere? Or is everything just hidden order we haven't uncovered yet? Let us know your thoughts in the comments below. There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.